Guys, welcome back. Week 4, day 1, and today we're going to begin with a new topic. Remember to leave that empty space so you can type there the topic's name, and at the very right, you place today's date. Today is November 15, 2021. So let's recall, let's remember a definition that we saw already on our first partial. Absolute value. What is the absolute value? Absolute value is the distance a number has from 0 on a number line. We identify it with those two little lines. We usually say that the absolute value is positive, okay? It is a positive number. So if I say, for example, the absolute value of -3, that would be +3, okay? Because we're talking about distance. Means I don't understand. Why is it 3? Because distances are always positive. So I was saying the distance from a number, so -3 to 0. Okay, that's what we're looking for. So let's see how many spaces we have. We have 1, 2, 3. So that's why it is +3. It's like your measurement. I'm not going to say that Natalie measures -1.67 meters. And I'm just making this up. I don't know what's her measure, her height. I'm not going to say that her height is negative. A height is always positive, even if you do it from your toes to your head or the other way around from the head to the toe. It will always be positive, okay? So that's why we said that absolute values are positive. So we can also say that the absolute value of +3 is how much? +3 also. Okay, so an absolute value is positive, but it's positive. It could be from a negative number or it could be from a positive number. So let's try that and let's make sure that it's 3. So we got 3 over here. So the absolute value of 3 is 1, 2, 3. In this case, since they're small numbers, we can actually count the spaces. But what if I say, what is the absolute value of -598? Are you going to be counting all of the spaces? No, right? You're going to say that the absolute value of -598 is 598 positive. Exactly. It is a positive number because it is a distance. We saw this already. So you are supposed to manage this already. Okay, so what are we going to see right now? We're going to see absolute value equations. Okay, we're going to see an equation that has an absolute value. So, for example, let's define that. Okay, let's define absolute value equation. Are equations that involve absolute values in the variables. Okay, so absolute value equations are usually equations that involve absolute values in the variables. And how do we solve an equation that has an absolute value? So to solve an equation in the form absolute value of capital A, okay, equals to B, where the capital A is a variable, okay? Or a variable expression, okay? Not only a variable expression, and B is greater than 0, okay? Greater than 0, then you're gonna solve A is equal to B and A is equal to -B. Okay, so it has 2 solutions. Why does it have 2 types of solutions? Because we have a positive value for a negative one and also a positive value for a positive one, okay? So let's see an exercise like this, okay? An easy exercise to begin with. So let's say that we have 2x inside the absolute value, okay? 2x plus 5, the closed absolute value, and that is equal to 11. That's our first example. Absolute value of 2x plus 5 equals to 11. So how are you going to solve this? You're going to do it this twice, okay? Remember, it says to solve an equation in the form of absolute value of A equal to B, where A, everything inside the absolute value is either a variable or expression, and B is greater than 0, then you solve A equals to B and A equals to negative B. So how do we solve that? I'm going to do it in 2 parts, okay? I'm going to do it. I'm going to say, the first one is going to be 2x plus 5 equals to 11. That's the first one. Okay. And the second one is going to be 2x plus 5 equals to negative 11. That's why A is equal to B and A is equal to negative B. Okay, so you're going to have 2 solutions. And we're going to solve this like a normal equation that we have been solving. Okay, like usually. So this 5 is adding, it goes to the other side, subtracting. So now I'm going to have 2x is equal to 11 minus 5. So 2x is equal to 6. Now this 2 is multiplying, it goes to the other side dividing. This is something that you already know how to solve since 7th grade, okay? So we're gonna have now that x is equal to 6 divided by 2. And 6 divided by 2 is 3, okay? And that is the first solution for the first part of this absolute value equation. Yes, Maria, this is the first part. Now the second part, it was going to be this one. Okay, so same thing. 5 is added, go subtracting, that part doesn't change at all. So now we have 2x is equal to negative 11 minus 5. So 2x is equal to how much?
Negative 16.
Negative 16.
Negative 16. Now the 2 is multiplying, goes to the other side, dividing as well, because it is multiplying. So we're going to have now that 2x, that x is equal to negative 16 divided by 2. How much is negative 16 divided by 2?
Negative 8.
Negative 8.
Exactly, negative 8. And that is the answer for this absolute value equation. Negative 8 and 3. You have 2 answers, okay? So you need to enclose both of your answers because it has 2 answers, one negative and one positive. Sometimes it might be both positives depending on the answer, on the procedure, right? It's not that usually one positive, one negative. It depends. It could be both positives. It could be one positive, one negative. I think that it might also be 2 negatives, but it usually is 1 and 1. Or it could be both 0, for example, okay? So that's like the or no solution, okay? Like the previous one. So that is absolute value equations. Any questions so far? No questions so far. Everything is good. Okay, now let's see the second part. That would be absolute value inequalities, okay? And just like the absolute value equations, these are inequalities, not equations, okay? Inequalities that involve absolute values in the variables. It could be only the variable that has an absolute value, or it could also be an expression like the exercise that we just did, okay? But also, just like in the equations, we also have some rules to solve an inequality. Okay, so to solve an inequality, in the form absolute value of A is less than B, okay, where A again is a variable expression. And in this case, B is greater than 0, and similar to the one that we just did, then we're going to solve like a compound inequality. We're going to solve negative B is less than A less than B. And you know already how to solve that because that's a compound inequality, which is the topic that we just saw. Okay, and that's the first type. Then we have another type to solve an inequality in the form absolute value of A, but now greater than B. The first one was less than, now it is greater than B, where A is a variable expression. And B is also greater than 0. You are going to solve A is less than negative B, or A is greater than positive B. Another compound inequality. This is for an and this is an or, which you also know how to solve, okay? Similar rules will apply if it's less than or equal or greater than or equal, okay? If this was less than or equal, or if it was greater than or equal. So I'm gonna place similar rules are true or apply, okay? For absolute value of A less than or equal to B. Okay, less than or equal to B. Or absolute value of A greater than or equal to B. Okay, same thing applies, same rules apply if it's greater than or equal or less than or equal, okay? Questions? Kind of trickier, right? Okay, so let's see an exercise that applies that. So let's say that we have, for the example, absolute value of Y minus 3 greater than 4. Okay, so let's see at the instructions. This is absolute value of 1 minus 3 greater than 4. So this one is for less than, this one is for greater than. So I'm going to use this second one, okay? Because it is the greater one. And it says that we need to divide it into a compound inequality that is called OR. So I'm going to say Y minus 3, okay, is less than negative 4. That would be the first one, right? According to this. Or Y minus 3 is greater than positive 4. And that would be my compound inequality that I get from this. Now I'm going to solve it in two separate ones, just like we solved our inequalities usually when it is an OR. Okay, so we're going to say Y minus 3 is less than negative 4. And we're going to solve that. So the 3 should go, negative 3 should go to the other side because remember the 3 specific rules that it says that all constants need to go on the right. So I'm going to pass this to the right, adding. So I'm going to have Y is less than -4 plus 3. So y is less than how much? How much?
-1.
-1. That's the first one, right? Let's go with the second one. So y minus 3 greater than 1. So y minus 3 greater than 4. So again, this -3 should go to the other side, add in. So now I have y is greater than 4 plus 3. So y is greater than 4 plus 3?
7.
7. And we're not done. Why aren't we done? Because we need to graph it. Okay, remember that we need to graph inequalities. So we're going to graph them. I open my arrowheads in both ends. The 2 little lines, whichever you want. -1 goes first because negative go on the left and positives go on the right. In this case, they're both open. Okay, so I'm going to graph this one in blue and this other one in green. Remember, we use 2 different colors. And the green one is greater than, so it goes to this side. And the blue one is less than, so it goes to this side. And we finished with this absolute value inequality. Questions? That's why we saw first compound inequalities before seeing the absolute value inequalities. We had to see that first. So question, what is the name of the topic? What is today's topic?
Absolute inequalities.
Absolute value? What else did we see besides
Absolute
inequality?
value in
Absolute
inequalities.
value inequalities.
Equations and inequalities, correct. Because we saw both. We saw absolute value equations and absolute value inequalities. And that is today's topic. We are still going to practice a little bit more of inequalities because this is an or. We haven't simplified or solved one that is an and, okay? So we might have different answers. Remember, we thought that we could have no solution, infinite many solutions, or real numbers, and specific solutions like in these cases. Questions? No questions? We're clear? Clear as water? Okay then. I'm going to give you a couple of minutes so you can copy this. And then this would be it.